In this session, we'll be talking about how to complete operations with fractions, starting with addition and subtraction, where the denominators are the same. Then, when one denominator is the LCM, or the lowest common multiple, and when the LCM is greater than either denominator. We'll cover how to multiply fractions across, and then simplify, but also look at cross-simplification and multiplying. Finally, when completing division with fractions, we'll be talking about using the keep, change, flip technique, and then simplifying. To start with, I'd like to show you what happens with regards to adding and subtracting fractions when they have the same denominator. If they've got the same denominator, that means they're both in the same terms, as with 1 over 9 and 4 over 9. As they have the same denominator, we can add the numerator and keep the denominator the same. And in this one, we get the total of 5 over 9. In the next one, we have 1 over 5 plus 2 over 5. So we can keep the denominator the same and add the numerator to get 3 over 5. If we move to subtraction, we've got 4 over 9 take away 1 over 9, which is 3 over 9, which we can then simplify by dividing both top and bottom by 3 to get 1 over 3 as an equivalent fraction. Next we have 2 over 5 take away 1 over 5. The denominator is the same, 5. 2 take away 1 gives us 1. Here we're going to look at the addition and subtraction of fractions where one of the denominators is the LCM, or lowest common multiple, of both of the denominators. So here we have 1 over 9 plus 1 over 3. The lowest common multiple of both 3 and 9 is 9, so we want to change them both into fractions over 9. Obviously, the 1/9 we can leave as it is, but the 1 over 3 we want to multiply the 3 by 3 to get 9 on the bottom. Whatever we've done to the bottom, we want to do to the top, so 1 times 3 would give us 3 over 9. Now that the denominators are both the same, we can make the denominator of the answer 9, and we can add 1 and 3 to make 4 over 9, and that's our answer. Next, we have 1 over 5 plus 4 over 15. We know that the lowest common multiple of the two numbers is 15. So we're going to convert 1 over 5 into something over 15. So here, the lowest common multiple of 5 and 15 is 15. So we're going to convert that 1 over 5 into something over 15. We have to ask ourselves what we did to the 5 to make it into 15, and that was times it by 3. So we're going to times the top by 3, which gives us 3 over 15. We've now got 3 over 15 plus 4 over 15, which means our answer is going to be something over 15. 3 plus 4 would give us 7 over 15. So now we have the subtraction 1/3 take away 1/9. As we know from the previous question, the lowest common multiple of these two numbers is 9. So we're going to convert the 1/3 into 3 over 9 again. We did that by multiplying the bottom by 3, so we multiplied the top by 3. We now have 3/9 take away 1/9, which will give us 2/9. In the last one, we need the lowest common multiple of 4 and 16, which is going to be 16. So here we have 1/4 take away 3/16. We know that the lowest common multiple of 4 and 16 is 16, so we're going to convert the 1/4 into 16ths. If we think about it, we need to times the 4 by 4 to get 16, so we're going to times the 1 by 4 to get 4. Now we have 4/16, take away 3/16, which would leave us with 1/16. Next, we're going to look at adding and subtracting fractions where the lowest common multiple is greater than either of the denominators. In the first addition question we have here, we've got 1 over 5 plus 2 over 7. Here, the lowest common multiple for 5 and 7 is 35. So we need to convert them both into fractions over 35. 5 times 7 gave us 35, so we times the 1 by 7 to give us 7 over 35. 7 times 5 gives us 35, so the 2 times 5 will give us 10 over 35. We can then add these two fractions together to get 17 over 35. In the next question, we have 2/3 plus 1/4. So the lowest common multiple of 3 and 4 is 12. Therefore, we convert them both into fractions over 12. So we times 3 by 4 to get 12. So we're going to times the 2 by 4 to get the 8 to go on the top. For the 4, well, we times that by 3 to make 12. So we're going to times the 1 by 3 to make 3. So now we have 8 over 12 plus 3 over 12. We can add those two together to get 11 over 12. We'll do a similar process when we subtract fractions. In this problem we have 2/7 take away 1/5. So again, the lowest common multiple is 35. So we can do these two fractions both as something over 35. We need to consider what we times 7 by to get to 35, and that was times by 5. So we times the 2 by 5 to give us 10. We times the 5 by 7 to give 35. So again, we do that to the numerator. 1 times 7, which gives us 7 over 35. So 10 over 35 take away 7 over 35 would give us 3 over 35. Lastly, we have 2/3 take away 1/4. The lowest common multiple, as we said before, of 3 and 4 is 12. So we're going to set that up in the two fractions as being the denominator. 3 times 4 gave us 12, so we're going to multiply the 2 by 4 to give us 8. 4 times 3 gave us 12, so we're going to multiply the 1 by 3 to get 3 over 12. We then end up with 8 over 12, take away 3 over 12, which gives us 5 over 12. To multiply two fractions together, you simply multiply the top two numbers together to get the new numerator, and then multiply the two bottom numbers together to get the new denominator. So here we have 1/5 times 3 over 6, 1 times 3 is 3, 5 times 6 is 30. We have 3 over 30. But we can simplify this by dividing both top and bottom by the highest common factor, which is 3, and we end up with 1 over 10. This method works for all fractions, but always look to simplify at the end. Here we've got an improper fraction of 5 over 1 times 4 over 15. 5 times 4 will give us 20, so that's the new numerator. 1 times 15 gives us 15, so we have 20 over 15. We can simplify these by dividing both top and bottom by 5, and we get 4 over 3. And we can then convert this into a mixed number by seeing how many times the 3 goes into the 4, which is 1. That's now the new whole number, and we have 1 left over, which we put over the original denominator of 3. So 1 and 1/3 is your final answer. Lastly, when you're using mixed numbers, they need to be converted into improper fractions before completing a multiplication. So here we have two mixed numbers, 1 and 2/3 times 2 and 1/4. We need to convert them into improper fractions. So firstly, the 1 and 2/3, we do 1 times 3, which would give us 3, plus the 2 would give us 5. So that's going to be 5 over 3. Then for the other mixed number, we have 2 times the 4, which give us 8, plus the 1 would give us 9 over 4. We can then complete the multiplication process. 5 times 9 is going to give us 45, and 3 times 4 is going to give us 12. So we have 45 over 12. We can simplify this by dividing both top and bottom by 3, which will give us 15 over 4, and we can then convert it into a mixed number. So how many times will 4 go into 15? It'll go in 3 times with 3 left over. So 3 is our whole number, and then that 3 that's the remainder goes over the original denominator of 4. So we have 3 and 3/4 as your final answer. When dealing with larger numbers in multiplication of fractions, you can try and simplify these before multiplying across. Here we have 5 over 12 times 3 over 10, which if we multiplied across would give us 15 over 120. Now we can see we can divide both top and bottom by 5, and we end up with 3 over 24, which we can divide by 3 to get 1 over 8. If we'd managed to spot the highest common factor, which is 15, we could have gone straight from 15 over 120 to 1 over 8. To save us time, we could look at cross-simplifying first. If we look at the diagonals, we can see that 5 goes into both 5 and 10, and I can cancel these down as follows. Here we can see that the numbers that are on the diagonal have common factors. 5 will go into both 5 and 10, and we could rewrite that as follows. It goes into 5 once, and it goes into 10 twice. The 3 also goes into 12, so we can simplify those. The 3 will change to 1, because we divide it by 3, and the 12, if we divide it by 3, will go to 4. Now if we multiply this across, it's already simplified to be 1/8. 1 times 1 is 1, 4 times 2 is 8. We can now move on to the division of fractions. And I always tend to use the method of keep, change, flip. It's a simple process that relies on the multiplication method that we've just gone through. Here, we have 5 over 12 divided by 3 over 10. I'm going to write k above the 5 over 12 because I'm going to keep that fraction, c above the symbol because I'm going to change the symbol, and f over the 3/10 because I'm going to flip that the other way round. So we end up with 5 over 12, change the symbol to multiplication, and then flip the second fraction to make it 10 over 3. We can then multiply it across and get 50 over 36. As they're both even numbers, we can divide them both by 2 to simplify it and get 25 over 18, which we can then change into a mixed number of 1 and then 7 remaining, which goes over 18. Lastly, when looking at mixed numbers in division, I need to convert them into improper fractions before proceeding with the keep, change, flip process. So here we have 1 2/3 divided by 2 1/4. So we're going to convert these into improper fractions first. 1 times 3 is 3, plus 2 gives us 5 over 3. Divided by 2 times 4 is 8, plus 1 would give us 9 over 4. I can now write the KCF initials over it to remind myself of what I'm going to do. I'm going to keep the 5 over 3, I'm going to change the division to multiplication, and then I'm going to flip the 9 over 4 to be 4 over 9. So I can now multiply this across. 5 times 4 would give me 20, 3 times 9 would give me 27, which is in its simplest form. To recap, with addition and subtraction, if the denominator are not the same, use the LCM, or the lowest common multiple, as the denominator and create equivalent fractions. Always check to see if one of the denominators is the LCM though first. When multiplying fractions, multiply across, but it's worth checking to see if you can save time by simplifying beforehand using that cross-simplification process. When dividing fractions, remember, keep, change, flip. Use this process to convert it into a multiplication, and then the process is as per the previous method of multiplication. In the next video, we'll look at the simple process to convert from fractions to decimals to percentages and then back again. I'll see you then.